Lady, you get the honor of starting today. So what I was hoping you could do is come up here and draw. You can bring somebody with you if you want, or whatever, call on people. Draw the rectangles for left endpoint. So yeah, yesterday we learned about left endpoint, right endpoint. Packets are on the bottom shelf in the back if you need one. Oh yeah, you don't have to ask about that.
Let's go.
Yeah. What? Okay. Ooh, didn't even bring anybody with. Oh, okay, you're doing the width of 10. That's fine. Oh, actually, this picture only had the 10. Perfect. That was the one we did in our notes, wasn't it?
Yeah.
Yeah, okay, because I was going to say, you keep staring at your notes. I guess I should have picked a right endpoint. Oh, well. Nice job. Perfect. Each one of those rectangles is decided by the left-hand side of the rectangle. The first rectangle is a height of 0, so you can't see it. Do you guys want me to go up and try to explain where the left and right came from again? Okay? No, but the picture is perfect, lady. So let's say the second rectangle, which is going to be easier to see. The second rectangle is from 10 to 20, and if it's called a left endpoint, you use the left-hand side of the rectangle to determine the height. So you basically would follow the left-hand side until it touches the graph, and then that's the height. If this was right endpoint, you do the exact same thing, except you take the right-hand side of the rectangle and you draw it until it touches the graph. And then that would be the height of the right-hand side. Okay, today is called trapezoid. Tyler, if I could, do you think that maybe that's one of the reasons you missed half the info? Oh, you think I'm talking to just Tyler? Let's see. Quit messing around with each other while we're learning things. Trapezoid method means you're not going to draw a rectangle. It means you're going to draw a trapezoid. Okay. Our first rectangle would be from 0 to 10. So there's the left-hand side, right-hand side. The height on the left is 0. The height on the right, I don't know what that is, 20? You're going to use both the height on the left and the height on the right. Actually, this was terrible. This is not a trapezoid. This one draws a triangle. But you are going to use the height on the left and the right. That one's not a trapezoid. That's why I just said that one actually was a terrible example because it was a triangle. The second rectangle, this would be the height on the left, this would be the height on the right. When I draw that rectangle, except not a rectangle, we connect both heights. So that shape is a trapezoid. So instead of making a rectangle, you use the height on the left and the right, both heights. The third shape, I'll stop saying rectangle. The third shape, this is the height on the left, this is the height on the right. And so they make trapezoids. Now, the trapezoid's not going to be perfect, but it's going to be quite a bit better than the rectangles. Like these last two shapes here, you can tell that they have quite a bit of, well, I guess I didn't even look. One's over, one's under. But for most of them, they're going to follow the curve pretty well. So there's two ways to do this question. One way is you're going to find the area of each trapezoid, which works totally fine. It's just super annoying because the formula for a trapezoid is so much more work than a rectangle. However, what they figured out after a while, I need another color here. Orange, sure. What they figured out after a while is that this trapezoid is exactly the average of left and right. If I drew the left rectangle and the right rectangle, the trapezoid is the diagonal between the left and the right. So if you know the answer to the left endpoint, let's pretend the left endpoint. So L5 meant left endpoint, 5 rectangles. Let's just make up an answer, or does somebody have the answer written down from yesterday? I have 0 idea. I see you have a number.
2,290.
Oh, did you get that from the key or something?
No, I didn't.
Just did it?
I did.
Okay, so 2290, I don't know. Oh, L5. And then the right endpoint, I think, was B. I think A was left, B was right. 30, 30. If you know both of these, the trapezoid method is the exact average of these two. So the trapezoid, if you know these two answers, this is a million times easier. So you would just add them, divide by 2. Now, most of the time on the AP test, you're not going to get that choice. So most of the time on the AP test, if they ask you to find the area with trapezoids, it is going to be from a table. I mean, exactly like this. They're not going to have a picture. It's going to be from a table. And so you're actually going to have to do the trapezoid area formula. Trapezoid area formula it's 1/2 base 1 plus base 2 times height. Now what confuses a lot of people is the trapezoids we have are sideways. This is the height. This is base 1. This is base 2. Because that's usually how they define a trapezoid. They define a trapezoid of having one set of parallel sides, and they call that the base 1 and base 2 of the trapezoid. So you would have to do this for all of them. Base 1 and 2 you have to find by putting a number into a function, unless you have a table like this particular problem. Usually you're going to have a function, but AP tests like to get questions in different formats.
Isn't that the same as the midpoint one?
Yes. Well, actually, the midpoint one probably will be the same. This particular problem, I don't think the midpoint will be the same because the way they drew it. So frequently, it's almost like a uniform set of numbers that they give you. So then midpoint would be the same as trapezoid. But trapezoid, kind of by definition, has to be identical to the average of these two. The midpoint can be and will always be really close. It's kind of goofy. Yesterday, I know I said the midpoint was the exact average, and in my head, I was thinking trapezoid. So I said midpoint for sure. I meant this one. Yeah, but midpoint is rarely used. It's used more in this packet than it is on the actual test. Does anybody want us to finish this question? Yes? Okay, then let's go through and do the actual answer, which I think is D. Okay, the first one is a triangle, so I'm not even gonna do the trapezoid. So, I guess I'll just call it T1 or something, first trapezoid. But we are going, oh, actually, we could do a trapezoid with a base of 0 and 20. It's kind of dumb, but will work. And then the height is 10. So this is still the same as a triangle formula. Trapezoid 2, the blue one, is going to be 20, I can't see the table. What is it? 28. No, that's not right. No, above 20. 52. You'll notice they always are gonna share a number though, because that's the way the picture is drawn. So like this 20 is the same between both of them. The next trapezoid is gonna start with 52. 80. So we've got 100 for the first one, the red one. The second one, average of 20 and 52, 36. 36 times 10 would be 360. Third trapezoid, the average of 52 and 80. 66. 132, yeah, 66, so 660. Fourth trapezoid, 78.5, so 785. Fifth trapezoid, what's that average? 75.5, so 755. And I most definitely don't know what those add up to. It's probably the answer I already had written down though. The average of 2290 and 3030. So it's probably gonna be 26. What is it?
2,660.
I don't know. I mean, it's 2600 something. This homework won't be difficult. Slightly annoying. What makes it go a lot faster is if you know how to use the table feature on your calculator or Desmos. I'm honestly kind of starting to be more favorable towards Desmos because it seems to be quicker to be able to type the equations in as well. But whatever you're more comfortable with is probably what you'll want to use because the table feature on both of them is going to be used a lot to find heights.
I use the table feature, but there's like an X and a Y, so there's base 1 and base 2. Yeah, plug in 2 things.
It's not an X and a Y, it's like X1 and X2. Are you talking about on the calculator or
On the
Desmos?
calculator. Because usually you can use it with 1. So you just plug in the table for 1 and then it gives you the answer, but there's 2
What do you mean a table for what?
Because you said the table,
Yep,
you plug in, say your X value.
it lets you plug in as many numbers as you want.
Okay.
Oh, have you always just done one, erased it, typed in another one? Got it. Oh, perfect, I'll just use that graph. You have to go to independent app. And then when you go to the table, so were you saying you would type one number and then erase it?
No, because there's two numbers that you have to plug in, because there's a base one and base two.
Yeah, so base one and base two would be like the left-hand side of the rectangle and then the right-hand side of the rectangle.
Oh, instead of doing the trapezoid. I was thinking,
What, okay, wait.
I was thinking the trapezoid formula for the table, and then you type in, because you can't plug in.
So the trapezoid formula, when you're talking about base one and base two, on a picture, base one would be the height on the left-hand side, base two would be the height on the right-hand side. So you would need to enter two different x's to find both bases. You're gonna have to, maybe what you mean is actually finding the actual answer.
Yeah.
Yeah, you're gonna have to write some down by hand any which way. I guess I don't know, does Desmos let you copy and paste? I haven't tried. Does it let you take the answer from a table and then just paste it in? Has anybody ever tried it? I mean, you would assume you could. If you can paste, then that would go a lot faster. Yes. So it'll probably be quicker in Desmos for the trapezoid just because of copying and pasting. I don't know. It just depends on how much you want to mess around and putz with little things that you may find annoying. There's not many trapezoid questions though, so they're virtually all rectangles. So don't worry too much about the trapezoid formula. It is 100% annoying to use. They're almost all rectangle formulas. So the actual work is not a ton. You're just multiplying two numbers. Okay, let's. I wanted some time for you guys to work, but I guess now it's just 5 minutes. So my bad. No, that's not it. Where's your notes? There it is. Okay.